Hi there, folks. Today we're reviewing some of these operations with polynomials, that idea of adding, subtracting, and multiplying polynomials. And so starting with adding and subtracting, remember, adding, subtracting, we can only add or subtract like terms. And one of the suggestions I would make is anytime we have subtraction, let's change it to adding the opposite, or let's distribute that negative sign so we don't have to worry about making as many sign errors, okay? So you can always change subtraction to adding the opposite, or essentially just distribute the negative sign and then combine like terms. All right. For example, something like this guy, and remember, like terms have to have the same variable and the same exponents. So as we look across here, I see all the variables are the same for these. They're all x's. But in order to add these things together, it has to have an x with the same exponent. So like, I can't combine the x to the third and the x squared. All right, those are not like terms. All right, what I can do is combine two of these that have an x to the third and x to the third. So these guys I could put together. And I can put those together because, again, they have the same x value. They have the same variable with the same exponents. And when I add them, I simply combine them by adding the coefficients and leaving the variable part the same. And so when you look at this one has a 1. That's a 1x cubed. So when I add these together, it's just 3 plus 1 is a 4. And then the variable part stays the same, 4x cubed. Let me scoot that down a little bit so I have a little more space to draw some of these things. Okay, and then I look for more like terms. I say, oh, what other variables with the same exponents do I have? And you say, oh, well, here's an x squared and an x squared. They have the same variable and exponent. So I can combine those. And when I add those together, a positive 2 and a negative 10 gives me a negative 8. So it's a negative 8 x squared. I add the numbers, but the variable part stays the same. And then continuing to scan here, I look at this guy. Well, this guy doesn't have any like terms, that minus x, so he's just going to kind of tag along for the ride. It doesn't change because there's nothing that I can add or subtract from it, so it stays the same, all right? And then these last guys, the negative 7 and the positive 8, those are like terms. They're just regular old numbers, constant terms. And so when I add those together, a negative 7 and an 8 gives me a positive 1, so I put down a plus 1, okay? Same thing with the next guy. Again, I'm looking for like terms. As I scan across here, there's only one x to the third. And so there's nothing to add or subtract from that. It stays the way it is. And then I look, and I always go in descending order is a good idea. So I look for the next highest exponent. I started with the x to the third. Now I look for x to the seconds. And again, there's only one of those. So I'm going to do that one next. I'm going to copy that guy down. Now I'll do the x to the first, and I do have some like terms here, the negative 2x and the plus 12x, and when I add those together, negative 2 plus 12 is a positive 10. Sorry, I switched colors here. Positive 10, and then the x just stays the same, okay? I add the numbers, the variable part stays the same, and then the negative 4 and the positive 1, when I add those together, gives me a negative 3. Okay, so just combining like terms. As I search for like terms, search in descending order. Start with the biggest exponents and work your way down, because that's the order in which we're typically supposed to write these anyway. Biggest exponent down to smallest. Okay, so combine things in that order. Look for like terms in that order. If I look at this one, once again, I have subtraction here, and I could go through and say, okay, this guy and this guy are like terms, and then I could subtract those. And then these guys are like terms, and I could subtract those. And these are like terms, and I could subtract those. But what happens is students tend to, these guys as well. Okay, like terms, and I can subtract them. But what happens is students tend to make a lot of sign errors when they do it that way. It's much better to change this to addition first before we start combining things. Okay? And so for this one, I'm going to change subtraction here. I'm going to change this to an addition sign. Now I just change the sign of everything that's in these parentheses. So a negative 2, a negative 6, a plus x, and a minus 1. Okay? And essentially, it's like distributing a negative 1 to each of these. It's like distributing that negative sign. So it changes the sign of everything. But now I don't have to worry about subtracting two things and thinking about, here I'm subtracting a negative or something like that. Now I just have to combine. Now it's addition. It's just combining like terms. Okay? And so these guys are like terms. I add the coefficients. That's a 6. The variable part stays the same. Next, these guys, once again, those are like terms. I add the coefficients. That's a negative 3. The variable part stays the same. Next, these guys are like terms. I add the coefficients. The negative 2 and the positive 1 is a negative 1. The variable part stays the same. And then the last one's the 9 and the negative 1. Those add up to an 8. And there it is. That's it. Everything's written properly in descending order. And I haven't made any sign errors because I distributed that negative. It's always easier to distribute the negative first. If I look at this one, same kind of thing. I have subtraction. I'm going to change that to addition, which means I distribute this negative. So it's a negative 3, a negative 1, and a plus 4. Okay, I distribute the negative, which changes the sign of everything. Now I just have to add up the like terms. Okay, and so as I combine like terms, here these guys are like terms, the x squareds. So when I add those together, that's a negative 1 x squared. And I didn't write the negative 1. If you write the negative 1, that's not a big deal. A lot of times we make that an invisible 1. All right. Next, I have more like terms here, the x's, the 3x and the minus x. When I add those together, that gives me a plus 2x. And now when I look at this guy, this one back here, the plus 4, that does not have a like term. However, the mistake the students make here is they end up writing down minus 4. Well, we can clearly see it's a plus 4, so I write down a plus 4. What happens is if you don't distribute the negative, because there's no other like term to combine with that, we tend to just keep the sign of what it has, okay? And so if I don't distribute the negative, I have to think of it as the first set of parentheses has a 0 and then minus that negative 4, which gives me a plus 4. So distribute the negative. It's going to save you on sign errors, I promise, okay? Talking about multiplication, multiplication is just using the distributive property. Remember, when I have polynomials, I just distribute each of the terms from the first polynomial. So I split this into a couple different distributive property types of problems. So if I look at this first one, I'm just going to distribute each of these individually. So I'm going to take the x and I'm going to distribute to the x plus 3. And this is kind of our shortcut version. I'm going to take the negative 1 and I'm going to distribute it to the x plus 3. Okay. The other way to think of it, kind of the longer way to do it, and this is what I'll do the first time, is I'm just going to say, hey, I'm going to take that first thing and distribute it to the x plus 3 and write it as a multiplication problem, as a regular distributive property type of problem. And then I say, hey, I'm going to take the negative 1 and I'm going to distribute it to the x plus 3. Okay. And so now I just distribute each of these individually. Here I distribute the x. And this is where my rules of exponents come into play. Remember, this is an x to the first times an x to the first. And when I do that, that gives me an x to the second. Okay? I add the exponents. Next, I do the x times the 3, which is a plus 3x. Over here, I'm going to distribute that negative 1. So I multiply, that gives me a negative 1x and a minus 3. And now I combine like terms. These guys in the middle, I can put those together. Those are like terms. And it looks like I ran out of space a little bit here. And so if I add those two in the middle together, that gives me an x squared plus 2x minus 3. There it is, okay? Taking a look at the next one, if instead of splitting this up, if I kind of do my shortcut version, I just say, hey, let me ignore that negative 3 and distribute the x. And so if I distribute the x, that gives me a 2x squared. So let me switch back to the blue. And a minus 4x. And now I'm going to distribute, sorry, I should have given myself a little bit more space here. And now I'm going to distribute the negative 3. So ignore the x and just say, hey, I'm going to distribute this negative 3. That gives me a negative 6x and a plus 12. And so now I combine like terms. Once again, those terms in the middle. The negative 4x minus the 6x gives me a negative 10x. And there it is, okay? Multiplied out. You can also use things like FOIL if you like, if you prefer that, and reminding yourself of first, outside, inside, last, that kind of thing. But again, just distribute each of those terms. Distribute the first term, distribute the next term. Keep doing that till you run out of terms. And now it's just a couple distributive properties and now combine like terms. If I look at this guy, same kind of thing. I'm going to show kind of the shortcut version again. If you need to split it up and write them separately, that's fine as well. So here I'm going to distribute that 4x to each of these, ignoring that minus 5. So when I distribute the 4x, that's a 16x squared and a plus 20x. And now I'm going to ignore the 4x and just distribute the negative 5. So when I distribute the negative 5 using multiplication, that's a minus 20x and a minus 25. And so now once again, I combine the like terms that I have, which are these terms in the middle. Well, here, the thing that's interesting, when I combine these, a plus 20x and a minus 20x, well, it cancels out. Leaves me with a 16x squared and a minus 25. And remember, this was a special kind of thing that happened because these guys right here, the original binomials, those are conjugates, which means they're the same thing with different signs. When you have the same thing with different signs, the middle term always cancels. And there's a shortcut that you could use there, but we really don't need it. If you remember the shortcut, go for it, okay? If I look at the next one, this is one that really messes with students sometimes because the temptation is just to take this guy and square it and then take this guy and square it, okay? But we can't really do that because it's that whole thing. It's the entire x plus 4 squared, which means when you talk about squaring something, it means that thing times itself. So if it's the entire x plus 4 squared, it's the entire x plus 4 times itself. So x plus 4 times x plus 4, now I can use my distributive property. Again, ignore the plus 4. I'm going to distribute the x. That gives me an x squared plus 4x. And now I'm going to ignore the x and distribute the 4. And when I distribute the 4, 4 times x is a 4x. 4 times 4 is a 16. Okay, and now combine like terms. X squared plus 8x plus 16. And there it is. That's it. Okay? So again, make sure when you have a binomial squared, you write it twice. It's that thing times itself. You have to use your distributive property to multiply that thing out. Something like this guy expressed the area of the rectangle as a polynomial. Of the rectangle as a polynomial. And so the area of a rectangle is just length times width. That's the formula for the area of a rectangle. So the area equals length times width. And for this one, the length and width are given as binomials. It says, hey, the length right here is a 5x minus 2, and the width is a 3x plus 4. So if I want to find the area, if I want to express the area as a polynomial, I'll just say, hey, the area is length, which is 5x minus 2, times the width, which is 3x plus 4. And so now this is just my distributive property. So saying, hey, let's multiply this thing out. I'm going to distribute the 5x. Well, that gives me a 15x squared, the 5x times the 3x. And then the 5x times the 4 gives me a plus 20x. Next, I'm going to distribute the negative 2. Negative 2 times the 3x is a negative 6x. Negative 2 times the 4 is a minus 8. And now I combine like terms, okay? So the area this time is represented by this expression, 15x squared. The 20x minus the 6x gives me a 14x, and then the minus 8. And that's it, okay? We don't know the actual area. We don't know what x is going to be, but we can write the area as this expression. And this is one of those classic things that they like to do on the Keystone exams, okay? Get you to multiply two binomials by asking you an area question, okay?